Hey there, my name is Ben Morss. I'm a developer advocate at Google, here to discuss with you core web vitals. What are they? How can I use them? Oops, that's not me at all. This is me. There's the same thing as before. You'll notice I'm not actually here in Brazil today. I'm actually in my home in New Jersey, close to New York, although I very much miss being places like Porto Alegre. This is from last year. You notice also in the background here, this is what I used to use as our attic in our house for a music space. It's now where I spend most of my time. So here we are. Instead of being in beautiful Porto Alegre, this is from last year where I spoke at Brazil.js, and I was there the year before. Instead of being there with you, I'm here again in New Jersey. And it's different. Instead of getting to meet some people and get to experience beautiful Brazil and go walk by the water over here and go to the mall there, and the Outback Steakhouse, all the wonderful things that you have. Instead, I'm over here where it's quite different. I had to stop recording this a minute ago because my dog was barking a lot. And then I had to stop because grocery delivery came. I had to go outside and deal with groceries and put those things away. And now here we are again. So this is not really a talk. I'm told that our workshop here can mean not so much a coding workshop where we get together, all work on code together and make something together, which we can't do because I'm recording this the day before, but less of a formal talk, more of a talk plus demonstrations and things. That is the approach I'll be taking today. Again, I wish I was here. Look at this, that's from last year. Look at that beautiful setup there at Brazil.js, but here I am. It's not bad though, because I didn't have to fly anywhere. See how excited she is. I didn't have to go anywhere, and get on a plane or anything like that. So anyway, this is more about core web vitals. So what is the point of core web vitals? The thing is, when people look at your website, of course you want them to look at your website and think, hey, look at this great content, incredible design, look how fast it loads, I can trust this site. I picked up my phone, there I was, bang, there's the website. But of course, not everyone experiences the web this way. As you know, if you're here at this conference today, people often are on phones with less power or on slower connections. Not everyone has 4G connections or the latest, greatest fancy iPhone or Galaxy or Pixel or what have you. Many phones sold today are lower powered, and those phones will execute JavaScript and, of course, things in the browser much, much less quickly. And often we're on 3G connections, even 2G connections. Actually, the last number that I saw was that the average website took 12 seconds to load on 3G on a mobile device. Again, maybe your customers or your readers or users are all on awesome connections all the time, but what about when they aren't? They could have a bad experience. In fact, those numbers that I've seen most recently also say that, in fact, 40% of mobile connections worldwide are still 2G. I know 2G is quite slow. I remember when I first went to Brazil, my provider gave me free data, but at 2G rates. So I couldn't load up most sites at all. And when I got a site that loaded up, I was so grateful for it. I wanted to find where I was going or something. I had to depend on my phone for that sometimes. So make sites that load fast as often as possible. Otherwise, you have guys like this over here who's looking at your site on his phone. He's frustrated by it. He's taken up smoking and drinking to cope with the stress of your slow site, and also some of my sites that are also slow, which I must fix tomorrow. So make your site faster. You can usually make sites faster. The thing is, it can be complicated to do so. And also, what metrics do we use? I mean, a lot of possibilities. There's when the load event fires, there's DOM content loaded, there's speed index, there's first contentful paint. What metrics should be used to figure out when things actually are fast? What if we could focus on some metrics that actually really talked about how a site really could load quickly and also could be more trustworthy? Like when you load the site, it's going to look good and things are going to move around a lot. So people have asked this question since time began. And during the last couple of years, a bunch of people from Google, the W3C Web Performance Working Group, other places have been discussing this and trying to figure out new metrics that really will reflect how fast and stable a site really is, and also be easy for people to use. And they came up with, in fact, Core Web Vitals, which was announced here on the Chromium blog back in May. Core Web Vitals are an initiative to have quality signals that we think are essential to delivering a great user experience on the web. We can't really discuss design with numbers as easily, but performance, and it turns out also stability, can be quantified pretty well. In this case, people at Google might say different things, different parts of the company. In this case, where we have our ducks in a row, everyone has discussed these things and agreed to discuss them in similar ways and similar metrics, making performance hopefully easier. And as you'll see, various tools across the Google universe have been unified to use the same metrics. I should mention also that search is on board with this as well. So these new Core Web Vitals will be incorporated into page experience signals to be part of ranking in Google search. You may know that Google search already will incorporate things like speed and mobile friendliness, HTTPS usage into its signals for search. Well, soon they're going to also involve Core Web Vitals. So soon, when will soon be? Well, Google was concerned because people are working from home now, and COVID-19 is still very much a problem all over the world. So they didn't want people to have to change things now. They'll be announcing at some point soon when it'll be 6 months until this happens. So you'll have plenty of time to work on this for your site if you're working on making your site perform a certain way in Google search. Again, there'll be an announcement about when it'll be 6 months. So this actually is really a pre-announcement. But you can start thinking about these things now because they'll still be useful. This also means changes for the top stories carousel in search, which currently is reserved for AMP pages, but will, when this actually comes out, be used for any page, except that page experience will be a ranking factor. So AMP will still be a good way to get in top stories carousel. This top stories carousel, I can just show you this real quick. You may have seen this before. I know it's also in Brazil. If you go to Google search, we're now simulating an iPhone. You'll look for some sort of topic. Let's say, I don't know, the election, which is a big deal over here in the US as I record this. You see this carousel over here. All these things here, I have a little lightning bolt in the corner. Those are all AMP stories. They use AMP, and they're all valid AMP. That gets them into the Google cache, the Google AMP cache that is, in this top stories carousel. There's more things here that get this little badge. What they're saying is that in the future, this won't be for AMP pages specifically. It'll be for pages that are ranked by their page experience scores. The belief is still that AMP pages will be most of these pages because it's kind of hard to match these performances without using AMP. We'll be discussing this at the end of our talk today, or our workshop, I should say. All right, so anyway, there we are. Okay, page experience. And there's another little slide that shows that top stories carousel open to all pages if they meet Google News guidelines, but page experience will become a ranking factor. All right, so before we discuss page experience, let's discuss these Core Web Vitals. What are these things? They're supposed to indicate, or supposed to represent, pillars of user experience, what a healthy site should have. These three things: is the page actually loading? Is the user looking at their phone or their device? Is anything actually happening? And then interactivity. Is the page responsive? The page might appear, if you're trying to scroll, click on a menu and nothing actually happens. This feels weird to the user because their phone is like part of their body. If they press something, it doesn't respond, it's just incomprehensible. It's like, is this thing broken? Even like a second of delay or a half second of delay, honestly, can be a pretty poor user experience. And then finally, visual stability. Is it stable? If I load this site, will things all just kind of appear in front of me and stay where they are? Or will they shift around some, which feels weird to people, especially if what moves in there isn't just an image, which displaces text, but like a video, or worse, a video ad. This can be disconcerting. And I've seen plenty of sites where things all shift around as they're loading, and it's just kind of bizarre. So these three things are three things we want to measure. Is it loading? Is it interactive? Is it visually stable? These correspond to the three current Core Web Vitals. I should mention that these are Core Web Vitals for this year. Every year these will be reevaluated and tweaked in some way because the web is always changing. People always get smarter about things, so we want to make sure that these things are up to date. So these things are called largest contentful paint, LCP for short, first input delay, FID for short, and cumulative layout shift, or CLS. I think if I press L, I'll get a little, ooh, look at this. See, there's LCP, FID, and there's CLS. That's pretty cool. So your goal should be that your pages should hit these marks here at least 75% of page loads on both mobile and desktop devices. It is thought over here that 2.5 seconds is pretty good, or less than that, for largest contentful paint. So when do things appear on the screen? First input delay, 100 milliseconds is pretty good. If it's like a second, that's pretty slow. And cumulative layout shift we'll be discussing. It's a number that's calculated in a way that we'll be discussing in a minute. So this data actually comes from the Chrome User Experience Report. So there's lab data and there's field data. Lab data we think of as you're on your computer, you're testing your site. How fast is my site on my computer? Oh, there it is. Okay, that's how fast it was. This is pretty useful. But field data is really something. That's actually people using your site in the field, actual people using your site on Chrome who've opted into sharing their data anonymously with Google and with Chrome. There's actually a searchable database called the Chrome User Experience Report. And PageSpeed Insights and other Google tools now use this. So we can actually tell how users actually are viewing your site in the real world. Kind of neat. I'm going to pause for some water. How are you doing? If you want to get some water to you can, I can't tell. So you're welcome to get up and get some water or a beverage of your choice. Let's look at these things now in detail. First of all, largest contentful paint. This simply is how long does it take for the biggest thing that's going to appear in the viewport to appear? The viewport meaning the stuff you see on your screen. Let's see, I've got a phone over here. The stuff you see over here. So I'm going to scroll down maybe and see more of the site. But until then, what do you see what appears immediately in the viewport? So there's various ways you can measure this. You know, there's load and DOM content loaded that are nice, but don't always correspond to things being on the screen. First contentful paint is a popular metric. It's a good one. Speed index is really great. Web page test uses speed index, but it's kind of hard to explain what it is. Really explaining it involves some calculus. This is really simple. It's just, okay, the biggest thing, whether it's a big hero image or a bunch of text or your logo, how long does this thing take to appear? And the user then perceives this actually pretty significantly. Oh, there's a hero image. The site's loading. That's nice. Again, largest contentful paint. It is thought that 2.5 seconds is pretty good. To get more details on this, you can go to web.dev. That link in the corner there, web.dev/LCP, is a great summary of largest contentful paint. Next one, FID, or first input delay. It's a time between when a user first interacts with the page until the time the browser can actually respond to that. Not load time at all, but okay, once the page actually is there and the user interacts with it in some way, how long does it take for the browser to be able to react to that? This can be delayed by long tasks, by things that are still loading up. If you're displaying something and the JavaScript involved to actually run it is still loading, or parsing and executing, or your framework is still booting up, that can cause a delay. And this can be strange, the uncanny valley thing. It's not about scrolling, by the way, just input events like a tap, a click, a key press, those kinds of things. So first we had LCP, second we have FID, finally a new one, cumulative layout shift, a new metric that's trying to measure how stable the load is. See that little diagram there on the right, if you have a button that says click me that appears and then your text moves, maybe you want to scroll, you begin clicking this thing by accident, it's not a great experience. How is this measured? It's basically how big the things are that move, how much they move. Specifically, if you take anything that moves and figure out what fraction of the viewport is this thing, and then how far did it move on the page? So the fraction of the size times the fraction of the distance. That is a layout shift number. So all the things that move, these things get added up. The sum of those things is cumulative layout shift. 0.1 is considered good, 0.25 is considered not that good. So for example, let's say your screen is 1,000 pixels and it moves 400 pixels, that's 40%. And if it's like half the screen, that's 50%, that'd be 40 times 50, that'd be, I guess, 20% or 0.2, already in needs improvement range. I can still do a little math. So again, for more details about these things, go to web.dev, web.dev/LCP/FID and /CLS. Again, these things are real user measurement metrics, RUM, to make it into a more cute way of looking at it. These things are all measured from real users, from Chrome User Experience Report. And they kind of correspond to different APIs that are used in the browser. The event timing API, largest contentful paint API, and layout and stability API. You can use these things to measure them yourself with JavaScript. If you're curious about why these were chosen, or why 75%, why these thresholds, here's my laser pointer. Go to these lovely bit.ly short links over here, bit.ly short links. These give you more information. They're quite useful. Check them out. So, believe it or not, this is useful. They did a study. Again, this is all findable on the site over here, how the study was done. When a site meets these thresholds, they found that users were 24% less likely to abandon page loads. 24%. That's significant. That's more users. If you've got an e-commerce site, you know, they've got to actually buy something. They've got to first start out by not leaving your page in the first place. So this increases your chances of people buying things by quite a bit. If it's a publishing site, people want to read things. It's just good. So, all right, that's good. They seem to work. And again, these are living metrics. So every year people will get together, kind of like they used to here with this map and the dog and the horse, and discuss these things. And they're going to point to their, anyway, people will be discussing these things also and making new ones for next year. Not that different, but a little different. So how do you measure these things? Well, there are many ways to do it. As I was saying before, people at Google have done various things across the company to all align on these web vitals. In some ways, you'll be using field data from the Chrome User Experience Report, some ways doing it on your own computer, some ways on someone else's computer, like a web page test does. All right, so going on here. Oh yeah, this is for all our ducks in a row. We're all aligned and have our ducks in a row. I blew this slide, but I can use a laser pointer to kind of do this. And isn't that cool? All right, you've come for content, not to see ducks. So here are 6 ways you can measure Core Web Vitals. As I was promising, people at Google have gotten together, aligned on these things, and made these things measurable in many popular tools. So for example, PageSpeed Insights now uses the Core Web Vitals and gives you this information from both lab and field data. The Chrome User Experience Report, again, you can do this. You can use this to measure it yourself, or rather you can retrieve information about user data from this. Search Console, Google's Search Console, you can use that, which is nice also. Chrome DevTools also has ways to do this. Lighthouse does this too. And there's also now a Core Web Vitals extension, which uses the JavaScript library, both of which you can also use. Note that for 2 of these, you can't actually measure first input delay because they're only measurable in the field. Without real users clicking on your page, you can't really tell how it actually is. But you can measure total blocking time, which is a pretty good proxy. I mean, if your page is being blocked from being interactive after it loads for a second, that's not good for users trying to press a button or click something immediately. So again, 6 ways to do this. We're going to go over all 6 of these ways. After that, we'll discuss ways to make your scores better. But first, the 6 ways you can do it. Number 1, PageSpeed Insights. This popular site lets you go ahead and test a site and get data on it. Let's do this because this is a workshop, right? So if you go to PageSpeed Insights in Google search over here, there it is. We can put in a site over here of our choice. You can see things I've done there before. Let's say we're going to look at, this is kind of a nice one. I'm looking at a Google site that maybe could use a bit of work. Many Google sites are very fast. Some sites are not always fast. Here it is actually running tests on a server somewhere out there in the universe and also retrieving data from the Chrome User Experience Report. 80% complete. Oh, there, look at this. So it looks like the Google Store needs a bit of help. The score there is a 12. If you want to see how the score is calculated, you can look at the PageSpeed Insights page. It discusses the formula that's used over here. You can see over here that first contentful paint could be better. The largest contentful paint could be a lot better. First input delay is good. Cumulative layout shift, not so good. So that could use some work. It gives you lab data, and also you can get details over here about what each of these things actually means. Timed interactive needs some work. So there you go, field data and lab data. And then it also will give you opportunities, ways to improve it. You also get this film strip showing how it loads. It's kind of blank for a while. So we've got some problems there with largest contentful paint. Some recommendations include removing unused JavaScript. Wow, that's really big, and they say it's unused, 614K. I guess some things that aren't being used at all. So diagnostics, interesting things. While loading your fonts, make sure text is visible then. Look out for third-party code. Main thread work. DOM size is pretty big there. A lot of stuff that's pretty useful. And then actually some audits were passed. It's not all a problem. Some things are good. Minifying CSS. JavaScript almost all minified. So this tool generally thought to be useful. Page speed insights. And there's more examples here. This is a non-Google site I ran this on before. You can see sometimes that pages need a bit of help. Again, we know it's hard to do this work. It's challenging. The goal is not to make you feel bad about it. The goal is to give you ideas for how you can improve things. As you improve them, the scores get better, everyone feels better, and just quite possibly, users are happier too. Number 2, the Chrome User Experience Report. This is the way you can query the user database yourself. Let's try this out. bit.ly/crux tool. You said I've been here before. I'm misspelling it. Crux tool. This describes more about the Chrome User Experience Report. I can use BigQuery to go ahead and make queries and search for stuff, how it actually works. Information here that's quite useful. Over here we have getting started. You can actually have this go to this guide over here, which is nice. How to actually use BigQuery, how to get started over here, how to make a project. Let's see. I think actually I've got a demo for you in a minute. Let's keep on going here. Oh, look at this demo. I've got actually a gigantic slide saying demo. That's nice. So here's an example dashboard I made before. And if I go to g.co/ChromeUX-, I believe I'll get a shortcut to doing this. So g.co/ChromeUX-. Here's Google Data Studio, emails, product announcements, market research offers from Google. And here we are. So it's now loading up some stuff. Let's put in a URL over here, store.google.com. And we go to connect. And we will find, hopefully, this site somewhere in the 4 million domains it stores. Okay, there we go. You can do all kinds of things here to filter your data by various dimensions. I won't. We're going to create a basic report over here. That's fine. Let's do it. So now it's going to do this incredible thing where BigQuery can go through terabytes of data, petabytes of data, who knows how much. And thanks to its amazing technology, make this pretty cool looking chart. There it is. And we get the kind of data over here about LCP, FID, cumulative layout shift, and all these things on desktop devices and on phones. You also can filter this again by 2G, 3G, and 4G users. You can make this chart prettier if you want to. It wasn't too bad to use, was it? That wasn't bad at all. You can do a lot more with this, but we're not going to because we only have an hour. All right, so that's the Chrome User Experience Report. Number 3. Funny I say actually number 4 here in my notes, but it's number 3, the Google Search Console. If you use Search Console, you will see that these Core Web Vitals are now populated right there in your console, so you can see the data there. Especially good for SEO people and non-programmers, so they can see here a nice little chart and nice color-coded things showing where the problems could be and where it actually helped fix things. All right, that's Search Console. Number 4, my favorite thing to do still, after all these years, is just go to my favorite dev tools and just look at the page myself. So is there more here? There's a little more here. Okay, let's go to a site again. Let's close some tabs because closing tabs is good. Let's go open up DevTools. Again, if you're using Edge, you've got the same thing now in Edge. If you're using Firefox, something else, there's different versions of various developer tools. I use this one for obvious reasons. Let's load up store.google.com. And I can just do this and look at it here and see how things load. Actually, better yet, even better than that, is simulating a mobile device, as I'm doing over here, and even throttling it to like a 3G connection. And seeing how it could be in the real world in sort of a not great connection. Not horrible, but not great. This is a fast 3G connection. And now we're going to load the page again and see how it looks. So a little slow. We're getting some things, which is nice. Now JavaScript is loading up and things are appearing. And I think we have images popping in now. Oh, look at that, takeover. See, that's a cumulative layout shift there. There's the image carousel popping in all of a sudden. That layout shift, we should be able to see that layout shift if we go over here to, where is it? Oh, I didn't do it yet, okay. You can look over here at the network tab and see all the things that loaded in order of loading. This is all the JavaScript that loads up over here. Notice over here the second line, 601K for this very large bundle. That could be a problem. You look at everything over here, you can see that this might be blocking something. First thing that loads here is this very large HTML. 274K is a lot of HTML, so that's kind of a lot of HTML. And then you have CSS loading and JavaScript, and CSS and JavaScript, and Angular is loading. All these things will be blocking anything from appearing on the screen. I think it's still the best tool because it's right there in front of you. You can look at everything you want to in detail if you want to. You can also, and this is my next slide I think over here, you can also go to the performance tab and get more information. So let's actually get let's get a recording over here of this. We're going to load the page again. I'm going to first actually just erase the entire DOM to start from scratch and go over here and hit Command E and then reload the page. That will profile this as it actually happens. It's profiling the load. It's loading, loading, loading. It's still loading. It's an awkward moment. It's taking a lot of time. Okay, I think it's pretty much loaded now. Let's stop this and look at this. And it's full of information about those 18 seconds we just saw. A lot of information, I guess. A lot of things are in there. You can see about where there were long tasks that happened, things like that that could be problems. We should also see somewhere in here, if I can just find it. Ooh, look at that zooming. Well, you can also find layout shifts. Let's see an example on this slide. Maybe this is simpler. Here's an example here in the experience area. It will flag in red here these layout shifts and describe where they happen so you can find these things yourself and see where it is in the load that layout shifts happen and you can fix them. Pretty useful stuff. What's next over here? Number 5. What is number 5 now? Sorry, it's already been a long talk over here. Lighthouse, the Lighthouse tool. You can use this in DevTools, and you can find the same information you get on the Page Speed Insights. It's useful though to have it right there in DevTools. So web.dev/performance scoring gives you more of that. If you want to see it over here in your own DevTools, well, there it is, Lighthouse. You can make a report and see all this stuff. Quite nice. Again, it runs on your machine, so that's going to be different from the user data you would see from somewhere else. But then you can actually try out sites that are less popular, like my site, for example. You can also try out changes, of course, and local things, and test information, test data on your local site. So Lighthouse, quite useful for development mode. And if I was going to look at my own personal site, it could be useful too. Let's try that. I haven't done this in a while. I bet this is going to be slow. This is benmorss.com. This could be a terrible idea. Okay, there I am. Hello, it's me. Make a report. Okay, this could be kind of slow actually. Let's let this run in the background over here and we'll do some more talking. We'll come back to this. Lighthouse, quite useful. There also is an API that it has. In fact, PageSpeed Insights uses Lighthouse API to get its own data for the lab data. It just runs on machines owned by Google. Lighthouse can be used in your browser, in PageSpeed Insights, or from a command line, or also a node module. Many ways that it can be used. Also, Lighthouse offers different advice for different kinds of technology stacks. So for CMSs like Drupal and Joomla, for example, you have these strings that will be advice that will be tailored towards the CMSs. There is advice tailored for WordPress, for React, for AMP, all kinds of things. How are we doing over here? Oh, it didn't actually work. Maybe I shouldn't be in a different tab. All right, so never happened, go away, bye. Let's keep on going here with our talk. Oh yes, also if you want to do this and as a part of your continuous integration, that's quite useful. So whenever you make a change to your site, run Lighthouse, check out the scores, see if they have any sudden like regressions or suddenly get worse in some way, and maybe you've actually put in a large image, added a lot of JavaScript, or made some change that made things slower all of a sudden. You can also use this for monitoring, of course. Every once in a while, test out your site and see how it's doing on Lighthouse scores and Web Vitals scores. And also for non-programmers out there, I made this thing a while ago for web page tests. People use this a fair amount who are non-programmers to just automatically test their sites every once in a while. This actually is an app script that runs in a Google Sheet. You simply put your URL in there, and then you start it up, run it every week automatically, and it sends you emails actually when certain metrics exceed certain values. If you want to look at this, there it is on GitHub, bit.ly/speeddemontool. I should change this to use Core Web Vitals instead, now that this is a thing. Or you could do it. So monitoring for the non-programmers out there, but you can set it up within a few minutes. Is that it? One more thing, number 6. You can also measure Web Vitals using this handy Chrome extension if you happen to use Chrome. If we go to bit.ly/Web Vitals extension, there it is, I've been there before. You can see this, I think it's going to be GitHub. There's the code and also a link over here. It is by Adi Osmani, by the way, the Chrome Web Store. You can then install it. I've got it installed over here. If I go back to a site that's more used than my personal site, say the Google Store again, and I go to my extension, which is hiding in here somewhere. I know it's here somewhere. Web Vitals. Oh, it doesn't have access to this site. That's weird. Why is that? Maybe a different site it has access to. Let's try that and see if it's any more accessy than the last site was. Lighthouse extension is there. Web Vitals extension. Oh, look at this. There, it does have access to this one, and there are some nice scores there. Look at that, CLS of 0.001. This is pretty good. So you can use it as a Chrome extension. You can also access the same code. This uses this code over here, which was created by Philip Walton and co. These are just JavaScript-based ways of doing the same things that Chrome does when it measures user data for the Chrome User Experience Report. You can just use this over here, import it into your project, and just use it as you wish. In fact, just like this, import these things from Web Vitals, and you can just go ahead and get your scores and do with them as you will. If you're also curious how these things are calculated, look here at the source code, and it's not that big. Take a look, see how it works. This calls for some more water. Okay, going on over here. So that's how you measure Web Vitals. Now let's say you've measured them and it could be improved. How do you improve things? An important question. It's the same stuff you usually would do to make your site faster. You can tailor these things though to certain metrics if you find problems with certain metrics. So for example, what causes problems with largest contentful paint? Just basically things that make things load slowly. So if your server is slow to respond, a lot of time to first byte, or just in general slow responses, it's going to make resources load more slowly, and it'll make, of course, content appear more slowly. Also, render blocking JavaScript and CSS. So making these things load up and even get parsed, and even execute before actually content appears on the screen will make the largest contentful paint, of course, slower. And then having the resources themselves load slowly, even by having a slow server response time, or a slow server, or very large resources that again will slow things down. And also rendering on the client will make things slow. If you can render on the server, that's better. Otherwise, JavaScript has to actually, again, load up and parse and run to show any content that's bound to slow things down. Let's focus on a couple of these things now for just a minute. Render blocking JavaScript and CSS, and slow resource load times, how to improve these things. If they're images, well, images are still the biggest thing on the web in terms of number of bytes, and maybe also in terms of time. So of course, make them smaller. How do you make them smaller? You choose smaller sizes, or you have to compress things. We all do this. We all load up images and forget to compress them, and suddenly you have 4 megabytes of images, and that's not good. One wonderful tool to do this is Squoosh.app. You probably have seen this before. If you haven't, you can choose an image and compress it right there in your browser using the magic of WebAssembly. I'm going to now try to find a picture here spontaneously that will be nice in some way. We're going to drag it in there. Oh, there's me. That's, all right, that's kind of big. So you can see the image over here, and you can actually change the compression and see if it's compressed more, how it looks. So here's already much, much smaller by using 75 as our JPEG. If we make this even worse, does it look much worse? Well, it's a little worse, but not much worse. And look at this. It's so much smaller, 84% smaller. I mean, for this kind of image, your quality can be really low because it's just me looking terrible outside of the POA sign over there. It still looks pretty good at 1/10 the size. Interesting stuff. Also, AVIF is now a thing. It's also a very small image format you can try out along with WebP and other such things. So a nice tool. There's many tools to do this. Also, of course, you should have images that are responsive. You should be loading smaller images for smaller devices. You can use source set and sizes to do this. You can use the picture tag to do this. Lazy loading is a wonderful way to do things. If you have content like pictures that are loading, below the fold, if you've got a whole site over here, images that are 3 or 4 viewports down, load those things later. Now, as part of HTML, image loading equals lazy does this for you. If you're using AMP, it's built into AMP. So lazy loading also will make the things load faster in the viewport so that while these things load that are visible immediately, you're not having things that are loading that are visible later interfering with those things. So many ways to make images better. Also monitoring is important for images because people load big images anyway and make things too slow. For JavaScript and CSS, same idea really. Less of these things and make them smaller. If you aren't using it on every page, then don't use it on every page. If you have things that aren't compressed, aren't minified, that makes them bigger, of course. Always compress. Unless you really can't compress, try to minify. The code coverage tool is a nice way to find things that aren't being used. That's in Chrome. You also can load things later. You can use async and defer for JavaScript, at least take it out of the head. The code coverage tool is pretty useful for finding CSS problems especially. Let's find an example of that. Let's go over here and try to get this to work. So here we are, application, where was it again? Code coverage, come to me. I think it's over here, coverage. There we go. Load the page again. And it will start capturing the coverage here. So you can see now that a lot of this JavaScript over here, much of it hasn't been used yet. Actually, most of it has not been used yet. And the same is true for other JavaScript libraries. And for the CSS, about 30% is being used of this over here. That actually is high. Often it's like 5% of the CSS is being used. You can go in there and get more details about what is being used, what isn't being used, and try to reduce things. If you can make your CSS loaded by part of the page instead of a big bundle for every page, load just what you need for each component on the page, and then combine those things, that makes things faster. Less CSS, better. Also for JavaScript, if you're using a framework that makes large bundles and you're trying to use various ways to roll it up and get it together and it's still large, try Preact. Preact is like React, but it's much, much smaller. Actually, the Preact core, when gzipped and minified, is just 3K. And migration isn't that hard. Try it out. All right, next. What causes poor first input delay? Well, long tasks, of course, because those get in the way of what's happening. Similarly, JavaScript that's slow to execute. Also, of course, large bundles that have to have a lot of JavaScript run before things actually work on the screen, and render blocking JavaScript. These are all problems that cause poor first input delay. Focusing for a minute on long tasks and long execution time. Oh, okay. We're not focusing on those things. But these are problems we discussed before in this talk. I'll try to break up long tasks into smaller tasks and try to run less code or run code after things already are available to be used by the user. Make them interactive first. What causes poor cumulative layout shift? Images without dimensions actually set, which we'll discuss more in a minute. Adds and embeds and iframes without dimensions also, same kind of idea. These things will cause things to shift around on the screen. Also, content that you inject into the page after things load. If JavaScript sticks in more content in there, that will again make things shift around. And also importantly, web fonts. Using web fonts carefully is important. Try to use them in ways that either have fonts be pre-loaded, so they're loaded early in the process, or try to avoid the dreaded flash of unstyled text. So for images, back in the old days, the best practice was to declare width and height in advance. That way the browser knew the size of things in advance and could leave space for things. That was the best practice before, but then with responsive design, that was harder because you couldn't tell how things were going to be. How big would they be for different viewports? You didn't really know. So you say, okay, width 100%, so how big as a container, set the height according to that, and the browser once again can't guess how big the other thing is going to be. It can't reserve space for it in advance, so layout has to be done again as the image loads up, as the size is revealed, and also things will shift around. To avoid this problem, the new best practice is to make sure the aspect ratio is correct. Because then, when the browser knows the width, for example, it can figure out the height from the aspect ratio, and it can then reserve space for things as soon as possible. So responsive design makes this harder, but still possible to minimize content layout, a cumulative layout shift. By the way, AMP does this for you automatically. All right, so speaking of all these things, page experience. We're nearing the end of this. This is our final topic here. Page experience, I said a long time ago, was the thing that Google search will be using as a ranking signal. What is page experience? Well, this actually is a thrilling conclusion of our talk, almost as thrilling as a giant dragon breathing fire, but not quite. Is that a robot on the right there? I think it's a knight of some sort. Anyway, I was saying before that Google search will be now using this new signal to figure out where to be we'll do the signal as a ranking signal in Google search. And also this will be used top stories carousel. My phone is now talking to me because I said, okay, Google at some point. So how will this be used? What does it mean? Page experience. It simply has core web vitals plus other signals. So what we just discussed for the last half an hour or so, plus other signals, which are mobile friendliness. Is your page mobile friendly? If not, that's going to get ranked a little lower possibly. Safe browsing. Is there any malware on your site? Are there deceptive content on your site? If so, then Google might rank it a little more low. HTTPS. Is your site's connection secure? That's also a ranking signal. And finally, intrusive interstitials. Do you have things that pop up on the screen and say, hey, subscribe now, hey, buy something? Are there things that take over the screen or block the user from reading content above a certain size? That can also reduce your ranking. These 4 things over here. So it's easier to make these things work if you use AMP. AMP, maybe you want to use, if you don't want to use AMP, it's certainly a choice that you have. But AMP is pretty good at these things over here, at LCP, FID, and CLS. In fact, we did a little study here and found that for domains that use AMP, 60% had pages that passed. For non-AMP, 12% did. So AMP has certain advantages. Why is that? Before I say that, Bento AMP is a new way to use AMP that can be useful for you, because if you use AMP in the old way, you want to follow all of AMP's rules, making valid AMP, follow all of AMP's restrictions. Instead of doing that, it may be easier if you have a site which is non-AMP to kind of start using AMP gradually, to start replacing things that are large JavaScript libraries with AMP components, for example, one at a time until you have a site that's just kind of faster. Bento AMP is making this possible. Currently, you can use components from AMP outside of the AMP runtime, but they may not always work. They usually will probably work, but it's not a guarantee. The Bento AMP project is kind of like a bento box of Japanese food. You can use these components without the runtime, one at a time. But sometime next year early, all the components that AMP uses should be available to be used in this way. Actually, they're using Preact for all the components now, and they'll work all by themselves. So it lets you kind of go ahead and bring some AMP into your life. If you don't like the AMP's restrictions, you can still use the components. Anyway, some advantages AMP has if you can use AMP for LCS, largest contentful paint. Well, it restricts you to 75K of CSS, so you can't have that much CSS in the first place. With JavaScript, AMP discourages you from writing your own JavaScript. Most of your JavaScript will be AMP's JavaScript, which is pretty small. You can use your own JavaScript, but only in certain contexts. So you have less CSS, you have less JavaScript. Also, AMP caches will preload and pre-render content for you. And if you use the AMP optimizer on your origin, it will also preload your hero image and pre-render certain things. So these things all make largest contentful paint scores better with AMP pages. First input delay tends to be better also. You have less JavaScript. All JavaScript is loaded asynchronously. And lazy loading is part of all AMP components. So things that are below the viewport will get loaded only when they're closer. And also AMP will do chunking of processes. I discussed this, I think, at Brazil.js 2 years ago. AMP will pause execution every few milliseconds, I think about 13 milliseconds or so, to give the browser a few milliseconds a chance to repaint the screen so it can try to have animations be 60 frames per second and avoid long tasks taking over the browser and taking over the thread. So again, first input delay also is better with AMP. And content layout shift, AMP requires all components to declare the height and width in advance, so that way they can just pop into their spots as they load, making content layout shift rarely a problem with AMP unless you use animations or things that move on the screen of that sort. Also, these things over here for page experience are easier with AMP: safe browsing, mobile friendliness, secure sites, and intrusive interstitials. Safe browsing often is a problem if you get malware on your site, which is often from injected JavaScript. If you're using a valid AMP, it'd make your page invalid. So you'd be warned by AMP early on that you had an invalid page because someone injected malware onto your site. With AMP, a very rare problem. Also, responsive sites are easier to make with AMP, making mobile friendliness easier. Responsiveness is part of all AMP components. You can choose, for example, the layout equals responsive type, and you can make any component or any image automatically shrink or expand as its container shrinks and expands. One last water break over here. Also, AMP requires HTTPS for everything you do. Any kind of server call you make, any kind of JavaScript you load requires HTTPS. So it forces you to use secure SSL. And finally, interstitials that are intrusive are banned from AMP. Ads that are intrusive are not allowed. And you can't usually make changes on the page until there's user interaction of some sort. So intrusive interstitials are harder to do. So it makes AMP tend to score better in all these areas. If you're using WordPress and you want to use AMP or try it out, try the plugin here, the new version 2.0, amp-wp.org. Let's get rid of Chrome DevTools over here. This will make it easier to migrate to AMP or bring some AMP into your site. It will help you get rid of JavaScript that will block AMP from being valid AMP. It'll convert images and videos to things that AMP will like. And it will actually, this is kind of neat, it will take your CSS and it will do tree shaking to remove CSS that's not being used. So it will be smaller for every page and fit within AMP's CSS limits. So AMP, again, an option to try to make your page pass Core Web Vitals and rank better with page experience. That was a lot of talking. I think I'm actually done with this over here. For more information on all these things, check out web.dev/vitals. Let's go there. You can go there to learn more about all of these things, all of these tools I've talked about, and try this yourself. So thank you so much for being here today. There's my site. There's me on Twitter. And thanks for listening. I hope this is helpful to you. And please find me to ask questions in the hallway or in the mall somewhere or in the chat or on Twitter. Thanks a lot and have a great day.